All right, so today we're going to demo the Snaky Lab for you. The first thing you're supposed to do in the lab is measure the length of the Snaky. And what we're going to say for the scale is that 3 tiles, 3 squares on the floor is going to be about a meter. So count the number of squares here. Hopefully you can see it. And that every 3 would be 1 meter. So write down the total length of the Snaky. All right, now they are going to do scenario 1 on your lab. All right, great. So look at scenario 1 and see, write down how many wavelengths you think that is, and so how long a full wavelength would be. And now they're going to move on to scenario 2. Sometimes it takes a minute to kind of get the rhythm of this. You can see it's not quite scenario 2 yet. That's pretty good. So it kind of looks like a standing wave. It should just be moving like up and down. You can kind of see the node in the middle there. So note how many wavelengths this is. So how long a full wavelength would be. All right, and then we're going to move on to scenario 3. You can always see right when it gets the rhythm of it here. You can see what scenario 3 looks like in the book. But there we go. That's pretty good for, there we go. Scenario 3 right there. So note how many wavelengths that is. There we go. It's kind of hard to get it to be exactly a standing wave where it looks like it's just moving up and down and not to the left. But note how many wavelengths that is and how many meters, in this case, 1 wavelength would be. There we go. Okay, so now what you're gonna do is time how long it takes for this to happen. So let's look at scenario 1 again. All right, so in order to time a complete cycle, think about there's a crest and a trough, crest, trough, crest, trough. So maybe count when there's a trough. And what you're gonna do is start at 0. So 0, 1, 2. And what you wanna do is count 10 cycles with this scenario and see how long it takes. You can either use the timestamp on this video or you can just use your stopwatch. Give you some time here to have 10 cycles. Start at 0 and go to 10. All right, and then let's go ahead and move on to scenario 2. Takes a minute for it to get kind of settled. All right, there, that's a little bit. So again, just pick one part. Yeah, I think keeps kind of going in and out. Yeah, that's pretty good right there. So just again, find a trough and start when it's on the bottom, a trough, and start at 0. And just go through and count 10 cycles. All right, and then go ahead and do scenario 3. Try to start when it's a standing wave. Pretty good. All right, so hopefully that was enough data for you to get your charts filled out. All right, so now we progress to the next part of the lab where we have stretched out the Snaky about 25% longer than it was originally. So go ahead and count the squares again. Remember, 3 squares equals a meter. So note in the lab the length of the Snaky right now. You can pause it if you need to. All right, and then we're gonna go ahead and do scenario 1 again. So there's scenario 1. So note, it's kind of the same thing as last time. How many wavelengths is this? So how many meters would one wavelength be? And then in order to get the frequency, you're going to have to time 10 cycles again. All right, that should be enough to get that. And then we're going to move on to scenario 2. That looks cool. And then again, note how many wavelengths this is, how long would one full wavelength be, and then you're gonna, ooh, that's good. Then you're gonna time 10 cycles. Do it when one of the crests is on the bottom, the trough is on the bottom. And you're gonna start at 0 and count to 10, and then you can figure out your frequency for this scenario. And then the last scenario, scenario 3. Ooh, perfect. There we go. Note how many wavelengths, how long one wavelength is. And then this is perfect. This is a standing wave. It should just look like it's up and down. Get your time during all these. You can rewind the video if you need to. Gonna time for 10 cycles and then do all your calculations.